This lesson is on section 8A titled Solving Inequalities by Multiplying or Dividing. So we're going to jump into the first example. So solve 7y, or 7 times some number, is greater than negative 42. Very straightforward, just like how we used to solve problems with equal signs. We got to get rid of the 7, we got to get y by itself. So the opposite of multiplication is division, so we're going to divide both sides by 7. So we're going to left with y is greater than negative 42 divided by 7 is going to be negative 6. Next, you can go back and check this too. It says y has to be greater than negative 6, so we can plug in, negative 5 into the equation. So we can say, does 7 times negative 5, is that greater than negative 42? Well, negative 35 is greater than negative 42, so it checks out. Next example says 1/3 times some number is less than or equal to 8. Okay, again, straightforward. In order to get rid of that fraction by our variable, we're going to multiply by its multiplicative inverse or by its reciprocal. So we're going to times this by 3 over 1. We're going to times this by 3 over 1. That cancels out to 1, so we're just left with x is less than or equal to, well, 8 times 3 is 24, and 1 times 1 is 1. So we can just be left with 8 is less than or equal to 24. And again, you can plug in any number less than 24 into our variable x to see if it's less than 8 in order to check it. For the sake of time, we'll just keep going here, but please make sure you go back and check your work. Next, this is a really important rule that comes up. When you multiply or divide each side by a negative number, the past two examples we divided by a positive number. So when you divide by a negative number, the direction of the inequality must be reversed for the inequality to remain true. So when we divide or we multiply by a negative number, we actually have to flip-flop the inequality. So I'm going to show you what this means and kind of what it looks like. So for the example, a divided by negative 2 has to be greater than or equal to 8. We need to solve for 8. Okay, so again, we can put the imaginary 1 in front. So we have to multiply this by negative 2 over 1, multiply this by negative 2 over 1. Now, because of this rule that we went over, because we multiplied by a negative, right here we're multiplying by a negative, we're actually going to flip-flop this inequality around. So right away, I'm going to flip-flop it around just so I know it's there. And then everything else remains the same. So this crosses out. We're going to bring the a down. And then we can put that one underneath. 8 times negative 2 is going to be negative 16. So my answer is a is less than or equal to negative 16. So, and again, I can show you why this works. So if I'm going to pick a number less than or equal to negative 16, a number that's less than negative 16 or equal to negative 16, I can keep negative 16 because it's, or the equal sign, so I can do negative 16 divided by negative 2. Is that going to be greater than or equal to 8? Well, negative 16 divided by negative 2 is 8, and 8 is greater than or equal to 8. Yep, 8 is equal to 8, so it checks out. And that's why you know that this rule actually works, is we actually checked to make sure it worked. Let's go to the next example. It says, Manny was trying to break his school's record by getting 61 hits in one season. Halfway through the season, he already had 34 hits. Manny averages 2 hits per game. Write and solve an inequality to find out how many more games it will take at that rate for Manny to have at least 61 hits. All right, so I'm going to set up my inequality. So he already has 34 hits, and he averages 2 per game. We want to set that up. That has to be greater or equal to 61 hits, because we have to figure out how many more games it's going to take. So we have our equation set up, and now I just have to solve for G, my games. We have to figure out how many games is it going to take to have greater than or equal to 61 hits. Already has 34 hits. He averages 2 hits per game, and that has to be greater than or equal to 61 hits. Okay, so I'm going to solve for G. I'm going to subtract 34 from both sides. I'm going to bring down 2g is greater than or equal to, and I'm just going to subtract here. 27. And then what I'm going to do is I'm going to divide both sides by 2. Because I'm dividing by a positive, I do not have to change my inequality. So it looks like 27 divided by 2 is about 13 and a half games. So it has to be greater than or equal to 13 and a half games in order for him to kind of break his school record. So that brings me to the end of this lesson. Again, you can always go back and check to make sure that works. But obviously you can plug in 13 and a half or plug in anything more than that for it to work. But please, the biggest thing about this lesson is this rule right here, that if you're ever multiplying or dividing by a negative, you must switch the sign. And if you're not dividing by a negative, just treat it as a normal equation and just bring down the inequality. And just be careful when you're checking your work. That brings me to the end of this lesson. Thanks for watching.